All right, this is our flipped class video for Honors Algebra 1, Section 9.8. And we will be referencing the factoring decision tree again, like we did in our last video. There it is. So if you have this, if you want to use this, certainly have that out. Remember, it's posted on your net classroom. There in your gradebook, you can print it out, use it in your homework, and get used to the thinking patterns we're talking about. So let's go ahead and get started with Section 9.8. We're going to be doing a couple of examples where we're factoring with four terms. And then we're going to do a little bit of a review from last time. Essentially, we'll do at least a couple of problems as a review. So I've got two of them here, factoring with four terms. You can see up to this point we've gotten as many as three terms, a trinomial, but now we've got four separate terms. So let's look at our decision tree. And here's the path we'll take. We'll factor out a GCF. Sometimes that'll happen, sometimes it won't. And then we go 2, 3, or 4 terms. It's going to be 4 terms this time. So then if 4 terms, it's really just one step. We're going to factor by grouping. That's going to be the path we take with these first couple of problems. So here's how we group. Just going to put parentheses around the first two. Parentheses around the second two. Because I have a plus, I'll just leave that out of the grouping, make things a little bit easier to see. Next thing I'm going to do is I'm going to factor the greatest common factor out of both of the groupings. So in the first grouping, I've got an x squared in common. What's left over is x plus 1. And in the second grouping, I've got a 5 in common. What's left over is an x plus 1. So we really do want the leftovers to match, kind of like what we were doing before. And now we're going to factor out those leftovers. So it's going to be parentheses x plus 1. Then we write our final leftovers. In the first term, it's x squared. Second term, it's plus 5. I want to be really careful here. I want to make sure that this x squared plus 5, I want to make sure that I consider that as far as factoring goes, because sometimes that will be factorable. So if we just think about that x squared plus 5 and we go on to the decision tree, what we would do is we would say GCF, there isn't a GCF. There's only 2 terms. Is it the difference of squares? Let's go back and look. Is this the difference of squares? Well, it's not a difference, it's a sum, and so it's not the difference of squares. So this is that lovely place where we say nope, so we're done. And so that can't be factored, so that is my final answer right there. All right, feel free to pause the video and try number 2 and restart and see how you did. All right, so we got 4 terms. So our strategy with 4 terms is going to be to factor by grouping. So once again, I'm going to group the first 2 and the second 2. So I'm going to factor out the GCF out of the first grouping. So the common factor there is p squared. What's left over is p plus 9. Now I'm going to factor out the GCF from the second grouping. And that's a 4. Leftovers there are p plus 9. So just like before, what I'm going to do is factor out the leftovers, the p plus 9s. So that's going to leave me with p plus 9 times p squared plus 4. Once again, I want to make sure that I consider this p squared plus 4 in my factoring. I don't know if I might be able to break that down a little bit further. But the truth is I can't. This is really similar to the previous one. If it was p squared minus 4, well, then I could factor that as the difference of squares, but it's plus, so I can't. Okay, you'll practice more with those in your homework. A couple of couple of review problems here. Words factor completely. That means we're going to need to use the factoring decision tree possibly. So we got 4m cubed minus 16m. So I'm going to get rid of this stuff. There we go. I've got 4m cubed minus 16m. Okay, so GCF first. What's in common there? There's actually a bit in common, right? Between the 4 and the 16, there's a 4 in common. Between the m cubed and the m, there's an m in common. What's left over? In the first term, there's an m squared. The second term, well, I had a 16, I pulled out a 4, so there's 4 left. And I had an m, but I brought the m out, so it's not there anymore. So I'm left with that. Okay, continuing on. You never want to finish this decision tree early. We want to take it all the way to the right side. Okay, so 2, 3, or 4 terms left over. We've got 2 terms left over. And is it the difference of squares? Well, it is a difference, right? We've got subtraction, so that's important. And is it perfect squares? Well, m squared is a perfect square, and so is 4. So this is the difference of squares. So the answer is yes, and we're going to factor using the plus minus pattern. Remember, here's how that goes. We're going to unfoil, so it's a double set of parentheses. The 4m does not disappear. Remember that m times m is m squared, and 2 times 2 is 4, and you just put the plus minus pattern in there, and now we're done. Okay, let's try a couple more. Yeah, number 4 is a good one. Okay, so with number 4, 4x cubed minus 4x squared minus 8x. Let's see if we can do this without looking at the decision tree. See if we can have this kind of start to get memorized a little bit. The first thing we always check is GCF. So what's in common amongst all those terms? Well, certainly they all have an x, right? And if you look at the 4, and the 8, they all have a 4 as well. So I'm bringing that 4 out. Here's my leftovers. X squared minus x minus 2. I'm just dividing out a 4x and undistributing it. Okay, now I look at my leftovers. Do I have 2, 3, or 4 terms? I've got 3. And then I need to check to see if a is 1. And of course, a is 1, right? It's ax squared plus bx plus c. So yeah, a is 1. So I'm just going to use, since a is 1, I'm just going to use the factors of the last to help me factor. So it's going to be, something like 2 times negative 1, or negative 2 times positive 1. And when I check these, 2 plus negative 1 is positive 1, so that's not what I want. But negative 2 plus 1 is negative 1. So we're going to write 4x. Remember, we're unfoiling here. So we're going to write it as x minus 2, x plus 1. And now we're done. Okay, I might skip around a little bit here. Yeah, let's do number 7. Number 7 for sure would be good practice. Okay, once again, let's try to do this without referencing directly the factoring tree. Notice the number 7, we're not at our starting line, so let's get there first. I'm going to get there by subtracting 250. So it's going to be 10x squared minus 250, and then subtracted from the other side as well, of course, is 0. That's where I want to be. I want to have everything on one side equal 0. So now, my first decision is always, is there a GCF? As I look at this, there is a GCF. Between the 10 and the 250, 10 goes into both. So it's coming out. There's no common x, so I'm going to write what's left over. I factored out a 10, so x squared for the first term. I factored out a 10, so it's 25 for the second term. Now look at your leftovers. How many terms do you have? 2, 3, or 4? We've got 2. So the next question is it the difference of squares? Well, it is a difference. And x squared is a perfect square. 25 is a perfect square. And so this is the difference of squares. So we're going to finish this, factoring at least, using the plus minus pattern. So x times x is x squared, so those go in the start. 5 times 5 is 25. So those go in the second part. And then we fill in the plus minus pattern. Okay, so this was solved. So we factored it, but now we need to finish it off by solving. So we're going to use the zero product property, which tells us that we need to set each factor equal to 0. So my first factor is 10, but 10 does not equal 0, so that's not one of my answers. But x plus 5 could equal 0, so could x minus 5. So my final answers will be x is equal to negative 5, and x is equal to positive 5. Of course, if you remember, you can write this answer as plus or minus 5. All right, that might be where we stop. Well, let's get one more review in. Well, yeah, let's get one more review in here with number 6. Back to just some factoring here. First step is always GCF. So there's not a common p in this. There's not a common variable, but it looks like there's a common 7. So I'm going to factor out a 7. Here's my leftovers. 2p squared minus 5p plus 3. Now look at the leftovers, 2, 3, or 4 terms. There are 3 terms. And the next question you ask is A 1? And A is not 1. A is 2. So we're going to have to use the split the middle method. And I need to find my AC. AC would be 2 times 3. Now I got to figure out which numbers multiply to be 6 and add to be the b. So, I mean, you can jump to this probably. 1 times 6 isn't going to work because that adds to be 7. 2 times 3 is not going to work because it adds to be 5, but 5 is obviously very close. Negative 2 times negative 3 is positive 6, but they add up to be negative 5. So it's going to look like this. 2p squared minus 2p minus 3p plus 3. I've just split the middle out. And now I'm going to sneak in a little bit of grouping here, just like what we did the other day. I'm going to factor out the GCF from the first grouping and also the second grouping. So the first grouping I see, there's a 2p in common. What's left over is p minus 1. In the second grouping, there's a 3 in common, but I'm going to factor out a negative 3 because remember from last time, I want my leftovers to match. So factoring out a negative 3. A negative 3 factored out of negative 3p is just p. Negative 3 divided out or factored out of positive 3 is negative 1. Again, the reason why I did that is I wanted my leftovers to match. So you want to be careful to notice that. Okay, my last step is going to be to factor out the leftovers. So that's p minus 1. And the 2p minus 3 is left over from that. So that would be my final factoring. Again, as a reminder, we haven't talked about this in a little while. You can easily check these by foiling and or perhaps distributing back together and hopefully end up with what you started with. Okay, well I think that's good practice for now. Hope this video is beneficial for you. I will see you next class.